Good evening to all. We'll start the lecture of today's class, that is GNSS. So the slide is visible to all of you.
Yes, sir. Slide is visible, sir.
Okay. Okay. Then today's class is introduction to GNSS, that is Global Navigation Satellite System. So इसमें हम different GPS system and different coordinates and different properties of the GPS system हम इसमें cover करेंगे. So there are four class of global navigation satellite systems. So today is the introduction class and some basics of the GPS and the history of some GPS operations to be covered in this class. So I think only two participants are there. Okay. Then PVSN Naidu sir is there, so we are also participants, sir. Okay, then we'll start. Um, then the navigations. So basic keywords are there in a GNSS, so navigation system. So navigation system में कुछ keywords है जैसे हम ज़्यादातर यूज करेंगे अभी different prospects में. So for the navigational satellite system, so navigation is most used for this, and navigation, it is defined as the process of monitoring, controlling the movement of a object or person from one place to another place within a specific framework. So एक चीज different places में जो changes होता है उसका movement होता है तो with reference to a framework, that means suppose for a particular region or particular frame, the changes of position of the object is called as navigation. So all these GPS systems are based on the navigation related. So that's why all are they are called as the global navigation system. So constellation navigation of satellite, commonly known as global navigation system. So generally, constellation means the group of satellite working together to provide positioning. So in GPS system, there is no one GPS satellite which cover all the global coverage. So इसके लिए क्या होता है कि suppose in GPS there are 24 satellites are there for covering the whole world. Then Galileo system is there. Then GLONASS. So all systems have a group of satellites, that covers in the global coverage or regional coverage. So this system is called constellation object or any part of the earth or space. Some satellites do GPS satellites are there. Their coverage of regional navigation satellite system area and determine the three-dimensional position means it determine the latitude, longitude, and altitude. That means x coordinate, y coordinate, and z coordinate. So there are three coordinates can be determined by the GPS system. Then GNSS means the Global Navigational Satellite System. All the navigational satellite systems like GPS, GLONASS, then BDO, then IRNSS, all are the GNSS system. That is a global navigation satellite system. So So it is initially used for defense purpose, and now it's used for civilian purpose like navigation, tracking, surveying, like GPS survey, DGPS survey for cadastral surveying, then transportation, mostly used in the transportation sector, then weather forecasting, then precise positions. So specifically, DGPS system is used for precise position estimations, and then navigation satellite system is satellite navigation based on the extensive network of satellites. Then display has to be radio signal in medium Earth orbit. So there are three orbits are there: lower Earth orbit, medium Earth orbit, then geosynchronous orbit. So ये जो आपका जीपीएस सैटेलाइट्स है ये मीडियम अर्थ ऑर्बिट्स में प्लेस होता है. सो इट्स हाइट अबाउट 15 to 20,000 kilometer above the earth. Then satellite navigation allow electro receives to determine their location attributes that which also cover latitude, longitude, and altitude, and to a high precision using time signal. So generally GPS में क्या होता है कि we use the radio signal. Radio signal means there is a longer wavelength signals given. That is LEO, that is low Earth orbit, then MEO, medium Earth orbit, and GEO, that is geostationary orbit. So each orbit have different height zone. Suppose lower Earth orbit, it is from 100 meter to 2000 kilometer. So in this zone, most of the Earth observation satellites, so which satellites are used for the different interpretations or any optical sensors are there. So mostly Earth observation satellites like LISPOR, Landsat data, Sentinel satellite data, then Worldview data, all satellites data which are related to Earth observations. तो इस हाइट में होते हैं बिकॉज वाई लोअर द ऑर्बिट ड्यू टू द हाई रिजोल्यूशन. हाइट जितना कम होगा सैटेलाइट इमेज का रिजोल्यूशन उतना ज़्यादा होगा. देन हाइट जितना ज़्यादा होगा सैटेलाइट इमेज का स्पेशल रिजोल्यूशन उतना कम हो जाएगा. सो दैट्स वाई ऑब्जर्वेशन के लिए हम डिफरेंट डिफरेंट जो सैटेलाइट यूज़ करते हैं तो लोअर अर्थ ऑर्बिट में जनरली होता है. जनरली 800 to 850 किलोमीटर के अंदर लोअर अर्थ ऑर्बिट होता है. सो इन दिस slides, it is between troposphere to exosphere. Most of the satellites. Then some of them are above the exospheres. So there is no any other satellites which are between stratosphere, mesosphere. So all these satellites are above 700 kilometers or 600 kilometers above the Earth. So there is the low Earth orbit, and then the medium Earth orbit is there. It is the height is between 2,000 to 20,000 kilometer, and most of the GPS satellites are there in this zone. And after that, then the geostationary satellites like the weather forecasting satellites are there. They are located in this geostationary orbits, which is 36,000 kilometer above the Earth's surface. So geostationary satellites are larger coverage areas due to the height. So these are the different observation orbits are there. So lower Earth orbit, then medium Earth orbit, then geostationary orbits. So generally the GPS satellites are in the medium Earth orbit sections. So most of the time these questions are arise. So I just cover this. Then the important term in GNSS system. So in the GNSS system में क्या है कि positioning is an important factor, real time positioning, spatial positioning, geospatial positioning, and geolocations. These are these terms are frequently used in the GNSS system. So the positioning, that means the use to describe the determination of location of one position related to other defined positions. So position means the latitude, longitude, and the height informations. This positioning related this parameters are used for the positioning of any location. Then real-time positioning, it refers to the obtaining location in real time with no delay between appearance in location and availability of position information about same location. Suppose in DGPS surveys, we use some real-time positioning data for accurately measure the precise locations. So the DGPS use the real-time positioning data, and some other defense uh, use are there. So defense purpose also use real-time positioning, and for aircraft flight moment, there is a real-time positioning is there. The spatial positioning is refers to the positioning system in determined to location of a object in space. So spatial positioning is we get the position data with the help of the spatial data like satellite data or some GPS informations are there. So based on the space-based information data, we can identify the locations, that is called as spatial positioning. Then geospatial positioning, the positioning with the geographical area with the help of spatial informations. So that is a geospatial positioning, just like just use the mobile uh, locations with the help of geospatial positioning. Then geolocation to identify the real world geographical location of a GNSS receiver. We can use some different receivers for the identify of geolocations. So these are some location related important terms are there in the GNSS system. Then definition of GNSS. GNSS collectively refers to the worldwide positioning, navigation, and timing determination capabilities available from one or more satellite constellation. सो जीएनएसएस सिस्टम जो ग्लोबली नेविगेशनल सैटेलाइट सिस्टम है, सो इसमें वर्ल्ड वाइड पोजिशनिंग, सो एनी पार्ट ऑफ द वर्ल्ड इज कवर्ड बाय द जीएनएसएस सिस्टम. देन नेविगेशन, real time navigations, and time determination. Main factor is the time determination capabilities available. So multiple satellite constellations are there. So some GPS systems are used um, two or three constellation data. So there are many global navigation satellite operating over the world. Likewise, there is a global positioning system, that is GPS. This positioning system is used by the USA. It is a global coverage. Then Galileo navigation system, that is a used by the European Union, and it is also a global coverage. Then GLONASS, it is from Russia, that is also a global coverage. Then video system, that is also called as a compass, and it is used by the China. Then quasi zenith satellite system QZSS, it is from the Japan. Then Navik India, also called as Gagan, and IRNSS, it is it is by the India. So Navik India is a regional navigational satellite system. Japan, जो QZSS also a regional navigational system, and other all Galileo, global GPS, GLONASS, all are global coverage. So global coverage needs more satellites. Uh, for example, GPS, that is used at 24 satellites, and now it's extended into 28 satellites, I think. Then these are some picture of the BDS regional coverage. This is the coverage of the BDS system of the China. So basically, it covers the China, India, and the Indian Ocean, and some part of the Pacific Ocean. So this is used for the strategic implementation and strategic planning. That's why it is mostly used, and for navigation purpose also it is used. Then coverage of IRNSS. This is the Indian navigational system. That is also coverage the most of the part of the Indian Oceans, and most of the Asian countries are covered. So these are the coverage. Then concept of ranging using time of arrival, that is TOA. So how this concept are used in the global positioning system. So basically the concept is the distance, velocity, and time. So these three factors are used for the positioning of particular area. So distance, we know that distance is a velocity into time. So here the distance is from known position to satellite to the receiver. So from satellite to uh, receiver, that is the distance. Then velocity of light, that is 3 lakh kilometer per second, the velocity of light approx 3 lakh. Then the time, because the electromagnetic radiations are traveling in the uh, velocity of the light, so we consider the velocity of the signals is equivalent to the velocity of light. Then time, so travel time of satellite signal. So from satellite to receiver, the how much time is required, how much time is taken to receive the signal from the satellite data. So this time is calculated with the help of different machines. So it is a basically travel time from satellite to receiver. So suppose there is some example is that the thunderstorm principle is there, which is similarly used in the global navigation system. Suppose a thunderstorm, um, suppose a lightning is flashed, suppose a lightning flash हुआ starting time, then we heard this sound after some 2 second or 1 second. So We know that the velocity of the sound is 330 meter per second. So lightning speed is 3 lakh kilometer per second. So the time delay we can calculate, and this time delay give us the distance between the initial point of the lightning to the receiver. So this principle is also applied. So suppose the time interval is 2 seconds from lightning to receiving the sound, then we can calculate the distance equal to the velocity into time of travel, that is 330 meter per second, that's the speed of sound, into 2, that is 660 meter. So we can calculate the position of the lightning is 660 meter from the person who can listening the thunderstorm after 2 seconds of the lightning. So I say this is the travel time, the eye determination of the start time, then ear determination of the stop time. So the distance is calculated, that is 660 meters. So based on the distance, the timing of the uh, thunderstorm is delays. So if more delay of the sound, then more distance of the lightning position. This is the principle. So same principle is also used in the navigation system. But in case of satellite navigation, electromagnetic signals are used which propagate at the speed of light. सो जब सैटेलाइट नेविगेशन सिस्टम हम बात करते हैं तो इसमें इलेक्ट्रोमैग्नेटिक सिग्नल्स आर यूज. सो इलेक्ट्रोमैग्नेटिक सिग्नल्स velocity is 3 lakh kilometer per second. So we use the velocity that is 3 lakh kilometer per second for calculation of the distance measurement. So difference between start and stop time is called as signal travel time. So from starting to stop time, that is called as signal travel time.
Sir, good evening, sir.
Good evening.
Sir, how can we calculate the start and stop time in satellite, sir? You are told that for thunderstorm, but how can
Yes,
we?
yes. So we cannot calculate the start time, but we can measurement the timing when the thunderstorm lightning is there.
Yes, yes, lighting I understood, sir. But regarding that satellite distance, you are told that 3 lakhs kilometers per second was speed velocity.
Yes.
Signal travel time, how can we calculate, sir? Start and start time, you are told.
Travel time, suppose we see the lightning at a particular time. After 2 seconds or 3 seconds, we can receive the sound of the
Yes, sir.
lightning.
Lighting understood, sir. Satellite signal,
Oh,
sir.
satellite.
Uh,
The satellite is not use the thunderstorm. Satellite in the same manner, when we use the positioning system, we just receive a signal from satellite. So
yes, sir.
this signal timing we can calculate with the help of GPS receiver. So this timing signifies the distance between a position of a person and the satellite.
Satellite, yes, sir. Yes.
So same phenomenon.
Okay, sir.
So in case of satellite navigation, that is same.
Okay, sir. Thank you.
Okay, thank you. History of navigation. So there is no such satellite system in 1950s. So a lot of radio signals are there. So this is the radio frequency. So from low frequency to sorry, for high frequency to low frequency, and the wavelength is uh, larger up to the radio waves. So in gamma waves, the wavelength is very uh, less, and the wavelength for visible light is 0.4 to 0.7 micrometer. Then infrared, it is greater than 0.7 micrometer. Then microwave remote sensing, then radio wave. So for radio waves, it is I think 1000 meter is the wavelength of a particular electromagnetic radiation. So we use the radio waves due to the penetrating power of this section to different cloud and different class. That's why use the radio waves for the navigations and the receiving the data. So the earlier land-based radio frequency was used to determine one position on Earth. So radio detection finder, that is RDF, first use of radio navigation system in 1930s. Then VHF omnidirectional range used for aircraft navigations. Then GE system, that is electronic grid of latitude and longitude by British. Then Omega by US Navy. So gradually it increased and the precision also increased. Then Loren long range radio navigation in 1950s. Then Lawrence C also used in 1992. So these are all uh, land-based navigation systems. So after that, then satellite-based navigation systems are there, and then transit known as NavSec developed U.S. Navy in 1960s. Then Navstar known as GPS, which are widely used worldwide, mostly in the mobile and in the different vehicles are used the GPS system, and also now the GLONASS also used. Then started the Galileo, then video, then IRNSS. So gradually the different systems are there. Then coordinate system. So for a measurement of position, that is latitude, longitude, and altitudes, and x, y, z coordination or coordinate. So we need a coordinate system. So this is the virtual coordinate system. Based on this virtual coordinate system, we can calculate the position and the different latitude and longitudes are drawn. So the coordinate system is a number that denotes a specific location with a reference system, that is assigning latitude, and height informations. So various coordinate system used in GNSS, that is Global Navigation Satellite Systems, are likely the geographic coordinate system, which is widely used in different softwares like ArcGIS, then uh, QGIS, and different GPS system. So it is a latitude, longitude, and angular based measurement. So from the center of Earth, we can use the latitude and longitude in the form of the angle. Then the celestial equatorial coordinate system used for astronomy. Then Cartesian coordinate system, it is a rectangular coordinate system that is used in linear measurement. So it is a XY coordinate system like that. So for latitude, longitude, in the Cartesian coordinate, that is in XY. So there are four quadrant is there. So each quadrant have different positions of the world. So it is signifies some position in XY data, XY coordinate system. Then height is in Z form. Then Earth center, Earth fixed coordinate system, that is ECEF coordinate system. So these are the coordinate system. ECEF, that is Earth center, Earth fixed coordinate system. So basically, it is also used by the geode informations are there. So a lot of coordinate system are there. Then GNSS system use. So different GNSS system use different coordinate system for the accuracy of the positioning. Then it is called the datum. Datum is the frame. So based on this frame, we can draw different projections and different latitude, longitude information, then XY coordinate system. So datum is just like the frame. Suppose we have the center of Earth, and we have the artificial Earth is there. So if the center of Earth, original center of Earth is our center position is nearer to the our center of Earth, that is virtual Earth, then it is very much accurate we get the very accurate position of the Earth. So if the center of original center of Earth position is far more than the virtual Earth center, then we get the value with a different errors are there. So datum generally targeted to more accurate to draw the center of Earth, virtual center of Earth. So datum describe the position, orientation, and scale relationship of a reference ellipsoid to the Earth. So different position and orientation and scale relationships are included in the datum. And the datum used in satellite navigation system are of physical and geometrical model. Physical model are based on the Earth's gravity fields, then gravitational gravity fields like geoid informations, then gravitational constant of Earth, then rotational rate of Earth, then velocity of flights. These are some physical models, and then geometrical model based on the precision, procedure, rotation of Earth, then orbit determination, polar motion, coordinates of satellite tracking. So most of the satellite-based informations are used for the geometrical models. So geometrical model also used very large uh, areas. So some of the examples of the datums are WGS datum, that is World Geodetic System. So it is a global coverage and it is maintained by the US Navy Imagery and Mapping Agencies. It is a global geodetic datum and it's Earth Center Earth Fixed Coordinate System. Previously we mm, observed that the Earth Center Earth Fixed Coordinate System is one of the coordinate system of GNSS. So it is also a Earth Center Earth Fixed Coordinate System. Most of the GIS softwares, GPS receiver use this datum. So in our GIS softwares, we use this WGS 84 datum informations as a reference for different projections. Then Indian geodetic datum is there. This is a local datum based on the average sphere. Some of time in Survey of India data, we also use this geodetic datum. Then Galileo navigational system. It is also a terrestrial reference system. It is aligned with the International Terrestrial Reference Frame. So International Terrestrial Reference Frame determine the datum validity and the accuracy of the different datum. So it measures the different factors for identify the errors and or shifting of the plates or other. For this, they calculated the modified informations and accurately determine the international frame of reference. So these are all these WGS. This is the WGS datum. Then it is the Indian geodetic datum, and this is the Galileo navigational system datum. Then these are the some height informations are there. Then the ellipsoid, geoid, and orthometric height. So generally we can calculate the orthometric height. This is the orthometric height, and we can calculate the orthometric height H is equal to uh, ellipsoid height minus geoid height. Geoid height is generally the equipotential surface of the Earth. So it is also imaginary lines. So based on the magnitudes and based on the density of the surface of the Earth, the geoid surface is created. So this is the orthometric height is equal to ellipsoid height minus geoid height. So in the surveying, we use this type of calculations. Then segment of GNSS system. So there are mainly three segment of GNSS, that is navigational satellite system. One is space segment, then control segment, then user segment. So generally in the space segment, all the satellites, GPS satellites are there. So GNSS consists of series of satellites that transmit radio signal continuously, so in different directions. And then the satellites are placed in a medium Earth orbit. So we also discussed um, that is the medium Earth orbit, that is 20,000 kilometer altitude. Then GNSS GPS receiver on Earth can receive signal from at least four satellites. So we, for the accuracy of our position, we use the four satellite informations from different directions, not for the one direction. So different direction for the accuracy. Then satellites are powered by solar energy, and if some power, solar power is fails, then some backup batteries are used to power to use this energy. Then each satellite constantly transmit radio signals using its own unique identification code and frequencies. So we will discuss later the different codes are there, pseudo codes are there, then other codes are there, and frequency are there. So we will discuss in next class. Then contain at least three high precision atomic clocks are there. Some atomic clocks are there in the GPS system for accuracy of the time measurement, and because in that they, because these are the moving in the very fast rate, so general clocks cannot really give the precise locations and informations. So these have the, these are the atomic clock which has the accuracy of 1 nanosecond. So it's a very high accuracy atomic clock is there. So a lot of atomic clocks are there. We will discuss later. Then signal can passes through glasses. These radio signals. Radio signals means generally the long wave signal. That is also called radio wave signal that can passes through glass, clouds, plastics, but not through the solid objects like mountains and buildings. So that's why sometime when we are in the field work or in the urban areas, we cannot get the accurate positional information, and we get a lot of errors are there. That's why we avoid some um, uh, acquiring the data in the building areas or to a open space. So we just get the data in the open space. So this is the some control component in the space segment, and user components are there. This is the total structure of functioning of the global navigational satellite systems. And this is used space segments can transmit all this data to the control segment, and also it is simultaneously receiving the all by the user segment. Then after the space segment, that is a control segment. So there are a lot of ground stations and networks are there that monitor satellite signals globally for health, orbit and clock data. Suppose कहीं पे अगर क्लॉक डाटा का इशू है या सब ऑर्बिट ऑर्बिट में कुछ इशू है, तो उसको ग्राउंड स्टेशन नेटवर्क में इसको कवर किया जाता है. देन मास्टर कंट्रोल स्टेशन आर देयर, which is central processing hub for tracking data and satellite commands. So some master control station um, is there. So इसमें क्या होता है कि ट्रैकिंग डाटा एंड सैटेलाइट कमांड्स उसको दिया जाता है. Then uplink stations transmit some navigational updates, correction to the GNSS system. So some uplink stations भी है जिसमें कि नेविगेशनल अपडेट्स एंड करेक्शन सैटेलाइट को दिया जाता है अगर कुछ अपडेशन चाहिए तो, फॉर ऑर्बिटल और एनी atomic clock related informations are there. Then orbit clock corrections, so it's your positional accuracy and calculating the uploading corrections are there. So these type of corrections are calculated. Then system integrity and maintenance, so continuously evaluate system performance and manage satellite operations. So these are basically control segments. So uh, we cannot go through this. Then user segments. So this is the segment where we can use this different um, equipment to get the information of the positions. The user segment includes all civil, commercial, and military GNSS receiver device that use satellite signal for positioning, navigation, टाइमिंग. सो जनरली जो हम मोबाइल में और जीपीएस में और डिफरेंट व्हीकल में यूज करते हैं, दैट इज द यूजर सेगमेंट. Then functionalities, it is in interpret the signal from GNSS satellite to determine the user's precision, location, speed, and time. Then applications widely used in surveying, agriculture, aviation, marine transportation. So generally हम जहाँ पे यूज करते हैं, अब तो widely use are there in the uh, use of the GPS system. Then types of receiver: single frequency, dual frequency receivers, multi constellation receivers. तो some कुछ सैटेलाइट, कुछ जीपीएस रिसीवर है जिसमें जीपीएस कॉन्स्टलेशन ग्लोनास एंड गैलीलियो, दो तीन टाइप का कॉन्स्टलेशन यूज होता है. और सम डिवाइस है ओनली वन constellation is used. So if the more constellation is there, then the accuracy of the information is more. That's why we used some multiple constellation data. Then performance factor, accuracy, availability, continuity, integrity, environmental condition, forward canyon, signal blockage. So these are some factors are there due to the some urban areas, some signals issues are there also. So these are some example and some of the device which are generally we are used for the user segment. Then it is then the atomic clock. So what is the atomic clock? It is why use atomic clock in GPS system. For the extreme accuracy, the measure time precisely up to nanoseconds, essentially for pinpoint positions. We use the atomic clock. Then accurate distance calculations. GPS calculate location based on the signal travel time. When 1 microsecond error cause 300-meter location errors. So generally in the general clock we use the minimum the second or millisecond, but in the atomic clock it use the nanosecond or microsecond. So 1 microsecond error causes 300-meter location error. That's why you use the nanosecond in the atomic clock. So it give the accurate information. Then stable timekeeping, maintain consistent frequency over long period and reducing cumulative errors. And then synchronize all satellites. All GPS satellites use the same time standard for triangulations. This is one of the important factor that all the satellites are synchronized with the help of this atomic clock. Then reduces user device complexity. Then GPS receiver rarely on the precise satellite timing or minimizing onboard time keeping needs. So for the time related issue, there is not and there cannot be found any error in the atomic clock. So very minimal error is there in the atomic clock as compared to the other clock. Then material used in the atomic clock. So various atomic clocks are there. One is cesium 133. There is a standard for cesium atomic clock defined as SI a second. Then this picture is one of the example of the atomic clock which is used in iron SS. Then rubidium 87 used in the compact clock, slightly less accurate but cost effective. Then hydrogen measure that is offer superior short-term stability used in the control segments. Then quartz oscillators, one of the atomic clock that is used in the atomic element for signal stabilizations and frequency generation. Then vacuum and microwave chambers to isolate atoms and control electromagnetic interactions precisely. So these are the some atomic clocks which are used in the different satellite system, and based on the accuracy and based on the requirement, the different clocks are used. Then this is the example. This is the cesium atomic clock. This is a picture of the cesium atomic clock. Then this is the rubidium 87 atomic clock. This is a capture zone, then interaction zone, then detection zone. Then microwave source are there, then clock signals are there. So this is the atomic clock of the rubidium 87. Then it is a hydrogen measure. The picture is a hydrogen measure clock. So these are the some parts of this, and the hydrogen distributions and some different parts are given in these pictures. Likewise, all these atomic clocks are used for different satellite system. Then some of the questions are there. So based on these slides, and we can discuss this. So today we are not cover all maximum questions. So only some 5 6 questions are there. So we can cover within this. So GNSS system are generally which GNSS system is a GPS, GLONASS, Galileo, all of above. So kindly
All the
answer
above, sir.
this. Yes,
All the above, sir.
yes.
Okay.
Is the all the above. Then during which year the project on GPS was launched? So it is 1973. Then global positioning system is operated by. So GPS is previously discussed. It is operated by Russian Space Force, China Space Force, United Space Force, and French Air and Space Force. So it is
See, sir.
used by United States Force. So because we are discussing all these questions, because most of the time in the UPSC or in different exams, most of the GPS related questions are there. So in the next class, we will discuss all the GPS related question and answer discussion, so that we will clear all related to these topics. So if any questions are uh, uh, arise in this in the exam, then we can handle it. Then a receiver at GPS calculate the self time and position based on the received data from different satellite or radio waves or atomic clocks or none of these. So data from the different satellites. So from the different satellites, we can use the receiving data. Then it's calculate the cell time and positioning. Then which is the present on the satellite of GPS to contribute the accurate time informations. So recently we discussed there's no antenna is not the time related issue. Then the atomic clock is
Atomic clocks.
to the time. Then compass satellite system of navigation is operated under this command. That's why it is a Chinese. So India is the IRNSS, European is Galileo, Russian is GLONASS. So these are the some basic questions are there. Then we will discuss later. So next class tomorrow we will discuss all the different signals related to the GPS and other parts. So if any doubt is there, we can discuss it. Would say Anmol, any doubt?
Yes, sir.
Anmol, any doubt?
No, sir. It's all okay. Sir,
So,
these are the you can share the PPT the which you are giving away.
वो आपको ये चाहिए तो you can
Yes, sir. We
uh,
can if you can in the group, sir. In the group, you can share the
okay, I will
PPT.
send it in the group. Okay.
Yes, sir. Yes, sir. Thank you.
Completing the
Thank
class.
you.
Okay, then if any doubts is there, then ask me. Otherwise, we'll conclude this session, and tomorrow we will discuss the rest of the part and some more about the UPS system.
Okay,
Okay.
Okay, sir.
okay,
Thank
sir.
you, sir. Thank you.
Okay.
Good night, sir.
Okay. Thank you.